So let's start this webinar. It's okay with you, William, Peter, and Robert? Yes?
Yes.
Okay. Good morning to everyone. And welcome to our webinars dedicated to the food, drink, and milk industries. The topic of today is about the opportunities arising for BREF in Europe. My name is Ivy Petit, and I am the Marketing Director of Veolia Water Technologies. So, the rules of this webinar. So I let you know that this webinar is recorded. All participants are in listen mode to make it more convenient for all of us. If you have any questions, feel free during the presentation to post it and to ask your question using the question box to the right of your screen. And we will cover that at the end of the presentation. So the agenda of the webinar. So it will last 1 hour. A lot of topics to cover around BREF. The Veolia Water Technology team is represented here, as you can see on the screen, by myself, Ivy, followed by Peter Stoke, Key Account Director, which remains your key contact. Peter will give you all key information related to BREF, and he will share with you feedback from the industries. Peter will be followed by Robert Koch, Industrial Application Manager. Robert will brief customer challenges. And finally, William Blanford, Industrial Sales Manager, will introduce you NutriPack technology, which has been just released in regard to BREF compliance guidelines. This presentation will be followed by a Q&A section, so we'll have around 15 minutes to cover your question. And as mentioned, feel free to ask it during the presentation. So the first part of this webinar is dedicated to the market insights, and I let Peter Stoke to take the lead of this first part. Peter?
Thank you, Ivy. Good morning, everybody. So as Ivy said, the first part will be to look at the BREF, what it is, who could be impacted, and timescales and so on. So to start with, looking at the European Union's Industrial Emissions Directive, so IED, and this takes an integrated approach to controlling pollution to air, water and land, and sets really challenging industry standards for the most polluting industries. The Industrial Emissions Directive aims to prevent and reduce harmful industrial emissions, whilst at the same time promoting the use of techniques known as BAT, or best available techniques, that reduce pollutant emissions, prevent or minimize environmental impacts of a site's operation, and also that are energy and resource efficient. This directive is a legislative act that sets out the goal that all European Union countries must achieve. However, it is up to the individual countries to devise their own laws around this legislation to see how these goals can be met. So the BREF contains not only the best available techniques in the reference document, but also the associated emission levels. And these are levels that must not be exceeded unless there is agreement with the relevant local competent authority, the EPA or such. There are many BREF documents covering many industries, but obviously today we're focused on food, drink and milk. And this document was released by the EU in 2019, December 2019. And it was published by the Integrated Pollution Prevention Control Bureau. And it was an update of the original document that was published in 2006. Now, this document containing the best available techniques and emission limits runs to almost 800 pages. So we're not going to cover all of that today. But it was put together after a consultation with a group of representative businesses from food, drink and milk industry, and also a number of NGOs and other stakeholders. so that they could really understand what could be achieved in the future in terms of air, land and water emissions, and what the potential impact would be. Now that that guidance has been released, manufacturers have until December 2023, so 4 years from the release of the document, to ensure their operations comply. The scale of the changes required to meet these new standards will vary from site to site and possibly country to country. So it's important that enough time is allowed to ensure the analysis, planning and implementation of any required solutions takes place. Okay, thanks, Ivy. Next. Next slide, please. Ivy, next slide, please.
Yes, this one.
Thank you. So in terms of where does this apply? So in summary, it's a factory that the treatment and processing of raw materials that is intended for food production or animal feed production. But there are some limits. If we take a factory that only processes and produces animal materials, then there's a limit of production. So above 75 metric tons a day of production, the BREF applies. Below that, it doesn't. Only vegetable raw material factory, the limit is 300 metric tons a day, and only a milk factory, an intake of milk over 200 metric tons. And there are some other small differences and complexities. So it's important that you really look at the document and see if your factory does require compliance. But again, I would stress that the EU Industrial Emissions Directive is the legislative act. The BREF guidelines are how to achieve that, but it's up to the local countries to put the law in place in their area, and then to work with the industrial factories to get compliance. Okay, next slide, please. Okay, so we're moving forward now in terms of specific emissions to water. So as well as the BREF document containing the best available techniques, it also contains the associated emission levels. And on the right-hand side, you can see a snapshot of that. And you'll see for the different parameters a range of a target level. So if we look at phosphorus as the example, the target range is 0.2 to 2 milligrams per litre. And it is possible for some countries to be more stringent with their interpretation of that, and others to be a bit more relaxed. And it is really down to the country environmental agencies to really work out where they fit, and then to work with the factories to what those new limits could be. In some cases, there'll be no change. In others, it could be more stringent. As with any compliance, ultimately non-compliance could lead to financial penalties, removal of license to operate. But I think that is really worst case, and there's a couple of years yet to make sure that that we can comply with this, the operators comply. And we're seeing a lot of growing communication with the environmental agencies to help them. Next slide, please. So we've very briefly looked at the emissions limits. If we start to look at the actual best available technologies, so in the document there is a BAT, so best available techniques, conclusions and decisions, and this is been applied for food, drink and milk. And in total there are 37 BATs contained in this document, all relating to air, land and water. The first 15, so 1 to 15, are really general and apply to all the food, drink and milk industry. And then 16 to 37, very much specific to certain sectors across brewing, oilseed, dairy and so on. as an example of that, BAT 21, 22 and 23 are specific for dairy industry. So 1 to 15, very much general across the industry, and then really specific. As an example, in the middle of the screen, BAT 4, which is the reference to monitoring emissions to water. And this covers things like frequency that should be applied to the monitoring, the methodology and the reporting. So it's not just about equipment solutions. This does cover things like hazardous chemicals, cleaning in place. There are a number of other BAT on environmental management and so on. So it really is important. This is a really important document in terms of a site's operation and compliance. Okay, thanks, Ivy. Next one. As already said, the BREF was released in 2019, so 2 years ago, December 2019, and a number of things have already been completed and a number of things are already in progress. So site plans to identify potential gaps to any new discharge limits, gaps in terms of compliance with the best available techniques should have already been submitted. We have seen some countries have extended timelines due to COVID and so on, but it shouldn't stop the factories moving forward with that, or from submitting a document to defer the implementation of solutions. In terms of Veolia's work internally, we've been looking at our complete equipment and services portfolio and how that could help our clients. There's been some work to develop some new solutions, which will be covered later. And now a series of webinars and really events to help support the industry and our clients to really help them meet any challenges they face. And that's where we are today. And as we see moving forward, we have 2 years to really work with the industry. Some clients won't have any challenges, we accept that. But where there are challenges and issues, we want to work with those clients, help them implement those solutions, probably within the next 12 months. So that gives them a good 12 months to help them comply and meet with the new limits before that compliance date of December 2023. Thanks, Ivy. Looking at some feedback from some companies we've been talking to, working with over many years, and we recognize that a lot of companies have been working for a number of years on their water reduction programs, wastewater compliance programs, and so there's a lot of factories there who this won't be a challenge for. It won't be an issue to meet the new levels because they're already in a good place. But what we're seeing is a number of companies taking this opportunity to really look at the additional sustainability improvements they could make, improvements to their environmental footprint, and also potentially bring in additional value through use of biogas, wastewater reuse, and that sort of thing. So companies are looking a bit further than just compliance. We're also hearing from some clients that there's a little bit in some countries, maybe some confusion about the new limits that the factories will face. It's not been rolled out completely yet, and so no definitive answers on discharge limits and so on. And we're also seeing, as I said before, timescales in some countries pushed back because of COVID. But what we would say is that it shouldn't delay a factory's move, as we've got 2 years left for compliance, really to start that gap analysis, make sure they are working towards that. Okay, thanks, Ivy. Next slide. We see from some countries as well a general experience from countries. As I said, the directive is a legislative act to what the goal is to achieve. How the countries achieve that is really up to them to put their laws in place. And we're seeing different things from different countries. Some experience in the Netherlands where a lot of industry discharge is direct to municipal. So there's no direct impact in terms of discharge limits to the operator, it's only a cost. But we are seeing, again, evidence of sort of increasing return on investment for them putting solutions in place. So that shouldn't be a barrier just because you discharge to a municipal wastewater treatment plant. Experience from Belgium, several instances where discharge limits, particularly on phosphorus, have been reduced because of discharge to small rivers, for example. So again, quite an important focus for some factories on phosphorus. And the UK, just you know, just to close this section, really some confusion over will they need to comply because of Brexit and so on, and it is the Industrial Emissions Directive has been enacted into UK law, so this will apply. So we're starting to see now some momentum gathered in the UK where companies are starting to move towards a better understanding and that December 2023 timeline. Okay, thanks, Ivy.
Okay, thank you, Peter. I will continue to give some insight because for the exercise of the webinar, we also looked, as Peter mentioned, at what the different stakeholders are telling us. We're now halfway on the road to compliance of December 23. So we wanted to hear if they see any delays or particular obstacles of any kind, technical or any. So I'm going to share some comments that we received and what we also saw in the documentation that the different stakeholders have published in the past on the internet. And actually I can recommend to look at some of them. The big document, the original document that Peter mentioned, is still a good source of information. If you look, you don't have to read all the 800 pages, but you can look for your sector, the specific BAT, and get some more detailed and background on that. So they did good jobs. You can still see webinars, papers, and yes, I think if you want to know more, it's a good place to start with. Generally, it's on its way in the FDM sector. The sites are more or less prepared. There are some delays in some cases. Also, authorities, due to COVID, also have to reduce a little bit the capacity to handle things, but it seems to be on its way. One thing that was made clear is that the deadline of December 23 will not change in any case so far. Also, there's good information available on the rules that apply, that the water agencies are willing to help out the sites. So they should be contacted, the ones that is in charge of the different sites. There might be still possibility to get some financing. And the BREF FDM is like the other BREF, not something that is there put forever. It's a constant revision, and there is talk about the next revision already for 2027. Another thing I wanted to share is that the BREF FDM has now become an international reference. There are cooperations and agreements like with Israel or exchanges with South Korea and Russia that show that you might see a bed showing up on some of your sites and outside of the EU boundaries. So this I wanted to share with you. Evie, next slide, please.
Yeah. Yes. Thank you, Robert. Thank you. This is my part now. So to know more about the industry feedback and to get an up-to-date return on experience of what is important for the actor concerned by BREF, we ran last October 2021 a campaign on LinkedIn. We call it LinkedIn Pool, to get more inputs about industry challenges. For doing so, surveys on our LinkedIn page focusing on water treatment. We asked visitors, as you can see on the screen, to vote for the most challenging environmental areas on the left and the most challenges that they are facing in regards to BREF. For the first post that you have on the left of the slide, we have an equal effluent treatment and water reuse on top priorities. And we should also mention that we didn't ask for feedback on production BIT, for example, air emissions, solid waste, and odor and noise. The question really focused on water treatment, and also to be noted that, as you can see, water consumption and hazardous chemicals were also considered as important, around 20%. Regarding the second post on the right, regarding the emission limit for discharge to the environment, the COD is #1 with 48%. So it's really on the first one, which is a key challenge for the visitors. So interacting with the end user is very key for us to make sure that the solution we provide and is the right portfolio in regards to their challenges. So now we will move on this solution that are dedicated to the BREF, which are available and that Robert will present now. Robert?
Yes. So next slide, please. Just a last look on the list of the bad conclusions. Today we have a 1 hour webinar, so we're not going to go into detail in all of them. As a company specialized in water treatment, we will focus on water today, and we will also not look into the details of the food production itself with technical details on evaporators or dryers or dust from milling machines. I think this industry is much better prepared and expert than us. So next slide, please. We did a matrix where we crossed the different BAT objectives with the technologies that are available on the market already today. And so we checked different issues that are addressed in the BAT, like environmental management, to see what are the solutions there, or energy saving related to water, resilience of the site against any upsets in the treatment plants, emergency preparedness. We looked at CIP, which is a major process throughout the whole food industry and drink industry. It is something to be looked at specifically. Of course, we look at water reduction, the different reuse possibilities and solutions that exist. Also, how to reduce consumption and effluent, improve effluent quality. This might be needed depending on discharge limits. And also they address hazardous chemicals as a separate issue, and resource recovery. Next slide, please. So to start out with, before coming to any conclusions what a site should do or needs, what we recommend is to do a water audit. To do water audits internally is already part of the best available technologies, part of an environmental management system in general. And many places, many sites have this in place. The BAT, however, encourages to do also external audits, which means that an external auditor with new ideas, with different view on things, comes on site and challenges the existing practices. We did over 80 audits in pharma and many of them in the food and drink and milk industry. And what is asked for in an environmental management plan for water is to do a water balance and a water map to see where the consumptions are, which processes consume how much, where the water goes, get a full understanding of all of this. And also at the same time in the discussions and looking at the data to see what risks and opportunities are there, maybe to reduce, of course, as a first, the consumptions and see what we can reuse, and even beyond that requirements, I would say. We have good examples where there are some very low-hanging fruits that can give sometimes 10-15% water savings just by looking at incidents, looking at practices. So that happens regularly. And of course, it's a good opportunity to benchmark with the other sectors and see what they're doing as best practices, and also where they are in terms of consumptions, and see if the differences that exist can be explained. Another bad objective is to reduce the use of hazardous chemicals, limited to the strict minimum, and also to reduce solid waste generated on the sites. That's not always easy, but there are some hidden, so to speak, solutions to that. There are green coagulants that can be provided, made, for instance, from tannin, and they have the advantage to reduce the sludge productions compared to metal salt that produce hydroxide. They are less acidic, so there might be less pH correction needed. In terms for the utilities, cooling towers are a source of water consumption and of chemical consumptions, and they can be decreased through the use of special technologies like controllers. You can reduce the water consumption. Or what we see is in high demand at the time is on-site generation of hypochlorite. Hypochlorite, as you may know, is not very stable disinfectant and biocide. The fact that you can generate it fresh on site reduces, of course, this aspect, and you do not have to handle large amounts of bulk hypochlorite. It also has a side effect to reduce the chlorate emissions into the water. So sometimes this is a criteria for the food industry to reduce the chlorate that's going into the product. Another solution to improve the emergency preparedness, of course, there might be special tanks, calamity tanks, but there's also solutions in terms of mobile water services, and they can be used to increase the resilience on site, because you know that you can call on them if you have a breakdown of an equipment and you want to replace equipment on site, the service through a service. It helps resilience because you can schedule in advance planned and unplanned shutdowns. And you might also think of it as a solution to cover seasonal water needs. For instance, during summer, you can decide to have a unit on site to produce your own reclaimed effluent and feed the cooling tower during high demand with reclaimed effluent. All this is available, and there's a service you can subscribe for free. A technician will come on site, look at the needs, and you are registered then that when an event comes that you are prepared, and we can in a very short time be on site and react. So that's something I encourage to do. It's for free. Digital services in general will also improve, of course, the performance, because it will allow you to follow online your KPIs. And of course, KPIs are necessary in order to continuously monitor your performance and improve your performance. It helps you understand the data, normalize, for instance, RO, reverse osmosis data, or improve your biogas production. That's another thing we have seen in the past. Of course, water and wastewater treatment monitoring gives you pre-alarms. So again, it builds resilience. And we have been asked specifically to create digital services that adds a lot of know-how to the operator that really formulates as much as possible already operator decisions, for instance, on CIP and other parameters. And next slide, please, Ivy. As I mentioned, CIP is throughout the FDM industry a major production step.
Can you speed up a little bit, please?
Yeah, okay, I will do my best. We have seen increasing demand here as well in solutions to recover caustic, and it's possible to recover caustic It helps you save, of course, on caustic, energy, and discharge costs on the effluent. Lab tests can be done, and are recommended to confirm that it works on site, and you can see you can recover very clean caustic soda. We also have cow water recovery in the portfolio, and it's on the market, different technologies from hygienic polisher RO or from UF RO with a biological pretreatment stage if the load is too much. And it allows to reuse 90% as permeate coming from milk evaporators, to be precise. MBBR is technical solutions to reduce the emissions to water. If you have an existing plant and you need, through BREF or other demands, you want to increase production, this is a way to improve and increase the performance of your existing conventional activity sludge plant. And the same is MBR. MBR is a membrane bioreactor, and it increases the performance because it gives you one of the highest effluent discharge performances. Again, it can also be retrofitted to an existing activated sludge plant. And the nice thing is you can also connect it directly to reverse osmosis and UV for reuse. Next slide, please, Ivy. Anaerobic treatment is probably one of the best fits on that objectives because resource efficiency and biogas and solid waste reduction are all in one, so to speak. You can also use technologies that allow you to reduce your sludge, your solid waste, because you can add it to the effluent and make biogas also out of your solid wastes. We have a good database for the FDM sector, so a lot of things can be done without heavy piloting, or we can do a simple lab test to confirm performance. And for resource recoveries, true white can be done on the effluent of anaerobic treatment very easily. Reclaim of effluent in general is done more and more with the limitations that you have to, in most cases, segregate the sanitary effluent from the process effluent. But there are references, and depending on the legislation in different countries, more or less is possible to be done. And again, there are containerized plug-and-play solutions that can be added quickly on site. I also like to mention reuse of different water sources like rainwater and air handling unit condensate. This is also done by ourselves. We have tools to predict what can be done based on internal weather basis and to optimize this process. We also have high recovery RO. They are on the market to improve recoveries above 75%, aiming for 95 and higher. They had the advantage of lowering, of course, the feed water quantity and the effluent, and also the energy consumption is very often improved. And it adapts easily to changing water quality, so very nice in reuse applications, where also less fouling is needed. Next slide, please, Ivy. DAF is again very popular in the food and bev industry because it has the quality to treat everything that is oil, fat, and grease, which is very often in the water and upsets downstream processes. And here again, there are new technologies on the market where you see that the white water is produced with less energy and also with reduced chemical demands. And through that, 40% of the sites are actually concerned by indirect discharges and need to do, in some cases, some pre-treatment on site. So this is a good technology to look at. We also have seen that weak acid cation water softening is entering into the industry. We have first reference in the beverage industry. It's a technology that is regenerating the ion exchange resin with CO2. And of course, this is now more and more in demand to reduce carbon footprint, and this is even a sink for carbon. So it also has the advantage that it's not salt regenerated, as I said. So this will reduce any chloride in the effluent. And we have seen that in the BAT, you have to now monitor chloride once per month. So maybe in the future, in the next revision, maybe there is some effluent limits to be expected. And last on my slides is effluent polishing and reuse. And we have the pleasure to have an expert on the panel. And I hand now over to William. He gives you more insight on that.
Thanks, Robert. And thanks everybody for attending this webinar. I'm going to keep my video off because I've noticed some bandwidth issues on my end. So hopefully this keeps the audio at a high quality. My name is William Blandford, and I want to tell you about our spotlight product for this BREF campaign. It's the Hydrotech NutriPack. Before I go into the details, please enjoy this short video giving an introduction to the solution.
Do you see the video, William?
Not yet. Oh, here it is.
I think it's coming.
Okay.
Yes.
Can you please go to the next slide, Evie?
Here you are. Yes.
Thanks. So an important part of the BREF guideline is the review of site discharge permits, which is mandated for all sites. While the guidelines have stated a phosphorus discharge consent of 2 milligrams per litre for food and bev sites and 4 milligrams per litre at dairies, it is feasible that the local environmental authority will use this as an opportunity to further protect the local ecosystem by reducing nutrient and/or organic discharge levels even further. It is generally accepted in the water sector that if the discharge consent is less than 30 milligrams per litre of TSS and/or 2 milligrams per litre of phosphorus, the most robust solution to consistently be compliant is a tertiary treatment plant. This can be achieved with a variety of technologies, but in the modern age, microscreens are considered to be the best available technology. Compared with sand filters, they are relatively inexpensive for both CapEx and OpEx, and are more resistant to spikes in suspended solids. Veolia Water Technologies microscreen brand Hydrotech has about 1,000 installations worldwide for effluent polishing, including about 50 in the food, beverage, and milk sectors. The microscreen is a simple piece of mechanical equipment which is designed to remove particles larger than the nominal mesh size. On the left is a diagram of a Hydrotech disc filter. Here, dirty water is fed into the filter where it passes through the woven filter cloth. Solids are trapped on the inside of the disc and clean water passes through. When a lot of solids build up in the cloth, it activates a backwash where the disc rotates and is cleaned by filtrate water from the tank. It is a continuous flow process and has a reliability of around 99%. The image on the right is a microscopic view of the woven filter cloth. The cloth will only stop particles larger than the pore openings, so it's critical that the solids coming to the filter are strong and well formed. That is exactly what the NutriPack is designed to do. Take particles in varying size and form them into well-designed flocks. Evie, next slide, please. The other function of the NutriPack is to precipitate nutrients. In the diagram, you can see two common food and bev process lines. So the top one is MBR to DAF, and on the bottom you see activated sludge. In either case, a microscreen can be used for effluent polishing. It is useful for reducing suspended solids or nutrients like phosphorus. When phosphorus reduction is the main challenge at your site, there are two common ways to tackle the soluble phosphorus. Dose coagulant upstream of the clarifier, which is shown in the purple box, or downstream of the clarifier, the green box. Each has advantages and disadvantages. In general, low discharge phosphorus consent requires better control of the coagulant dosing, in which case it is more reliable and efficient to do downstream the clarifier. Some of the listeners may have seen the case study we made for a dairy in Hungary, where the wastewater recipient is a bordering creek to an international neighbour, so exceeding discharge limits could lead to a diplomatic challenge. In this case, the compliance total phosphorus discharge limit is less than 0.7 milligrams per litre, so coagulant dosing is done between the clarifier and the filter, the green box. Beyond the compliance aspect, the decision of where to dose coagulant becomes a CapEx-OpEx trade-off. Dosing coagulant upstream of the clarifier will have a lower CapEx investment. Dosing coagulant downstream of the clarifier means that the dose concentration can be optimized. Reduced organic material downstream of the clarifier for the coagulant to react with means much less dosing is required. The result is that the sludge production will be significantly reduced, and because there is less chemical sludge in the activated sludge plant, there is more space for the good bacteria, which will lead to a more efficient and more stable wastewater plant. At Veolia Water Technologies, we have chemical experts who can help optimize these parameters and tools to help you calculate the return on investment for the plant. Next slide, please. Evie? Ivy, next slide, please.
Yes, we didn't hear the last sentence. Sorry.
Okay. I was just mentioning that at Veolia Water Technologies, we have chemical experts who can help you optimize the dosing parameters, and we also have tools to help calculate the return on investment of new investments. But what I want to mention on this slide is that it's basically why we developed the Hydrotech NutriPack. The feedback that we were getting from the market was that the microscreen filters installed at industrial locations were causing customers some headaches. Because of our strong success delivering well-functioning plants to the municipal sector, we had basically copied and pasted the design approach. But industrial wastewater plants are not the same as municipal plants. There are huge swings in organics and nutrients, which demand a system that can be both responsive and robust. We realized that we need a dedicated product for industrial customers. The diagram shows the process flow of the NutriPack with an emphasis on the smart controller. This is a feature which enables us to offer significant chemical savings while achieving compliance. At one site, we saw the coagulant consumption drop by 70% after installing the smart controller. Our market research has also revealed that site works are very expensive at the moment. With the package plant, you can avoid concrete and labor costs. The equipment is quick and easy to install. It can be up and running at your site within 16 weeks of an order confirmation and will not affect day-to-day operations. Finally, one of the most important features is that it is a hands-off tool. We have designed it to be easy to keep online. Special features like semi-automatic deep cleaning have been included to keep the maintenance demand as low as possible. And Veolia Water Technologies offers a complete digital and service package to further reduce the demand for the operator's time. So if you want to hear more about this or any other solutions we have presented today, please contact your local Veolia Water Technologies office. Thanks for listening to my part of the presentation.
Thank you very much, William. So now we are at the last part of this presentation, so the conclusion. So I let the floor to Peter, Key Account Director, that will share with you the key takeaways of this webinar. Peter?
Okay, thanks very much, Ivy, William and Robert for your presentations. I think just to close in the next minute, the key takeaways for as we see things and we talk to clients and industry agencies and so on. So the compliance is necessary. We've got a closing timeline for December 23, which is going to impact some factories, but not others. But compliance is necessary. But we also see a lot of opportunity to bring added value for your site operations and your business, to reduce your operational costs and improve your environmental footprint. So, you know, I think, yes, compliance is necessary, but opportunities for a significant return on investment where you're making improvements. From Veolia Water Technologies view, we really want to be seen as a partner, not just an equipment provider. So really looking at the whole process from audit to design of solutions, to supply of equipment, but also systems and services, and really help our clients and the industry with any challenges that they may face in terms of implementing the BREF. With a view that the timeline is quite tight. December 2023 will be here very shortly. So we've tried to design and enhance our existing equipment, and as you've seen, new solutions as really compact packages. So less civil works, less civil cost, faster implementation and startup to allow you to get your plant commissioned and running and compliant way ahead of the timeline. So I think those are the three key takeaways from our side. Really interested to hear any feedback that you might have in terms of your actual experience with this, how you're facing the challenges, what challenges you're facing, if any. And again, I'd sort of put the call out that if you are facing challenges, you need some help, please do not hesitate to get in touch with us. We're very we want to support you, we want to help and meet this next step for December 2023. So thanks very much for attending. We're going to open up a Q&A. I know we've had a couple of questions already, but I'll pass over to Ivy to walk us through the Q&A. Thank you very much.
Thank you, Peter. So if you have any questions, so you have Peter contact information. So feel free to post your question, you know, in the chat box dedicated to question, and I will ask this question to the experts. So I'm waiting a little bit question to be posted. We have one first question just coming that I read to you. I think, Robert, this is for you. So I let you know about this question. So the question is for CIP. We understand the BREF recommendation is to reuse caustic solutions as a best practice. How is this done in practice, Robert?
Yes, there exist different technologies. Some are on the more on the chemical, physical side. They're doing some coagulation, flocculation, and settling. The ones that we have presented today on using ceramic ultrafiltration membranes. And what we do is based on the consumption data, the amount of caustic that is consumed per year, the amount of water that is consumed. We make a first estimate, first economical assessment, if it's worthwhile, based also on the unit costs of caustic that are fluctuating quite a bit. And yes, and if that's a green light, then we go and propose a lab test, which within a week gives enough information and testing on different types of UF membranes, what can be achieved. Visual aspect, but we also monitor turbidity and color. Yes, and we also have to then talk to the site and see if there are any particular issues on allergens or on color, if they're switching from chocolate to a white product. This all needs to be analyzed, and yes, and then we make a firm proposal for a recovery unit. That's the way it would work. And it has been observed that the recycled caustic is actually sometimes even better than the fresh caustic. That has been observed.
Okay, thank you, Robert. We have another question. I think, Peter, this is for you. We have always seen BREF documents as guidelines, so they are not really enforceable. Is that right?
Well, hopefully the first part of the presentation showed that. So yes, the BREF documents are the.
Peter?
Yeah. Hello, can you hear me?
Yes.
Yep. Okay. So
yes.
The
yes, perfect.
Okay. The BREF documents are the best available technique reference documents. So they are there to support the best available technology implementation. As I said at the beginning, the Industrial Emissions Directive is the legislative part, but it's up to the local countries to put their own laws in place to achieve the IED goals. So from that point of view, yes, it is enforceable as any environmental discharge limit would be. So BREF in itself is the guideline, but there will be laws around that by 2023, by December 2023.
Okay, thank you, Peter. There is one other question. I think it's also for you, Robert. So this is a question. Is it possible to reduce pollution at source instead of at the end of the process? And what are the techniques that could be employed? And another one in the same. And can solution for nutrient recovery also be employed at source? It's
yes.
clear, Robert?
So there are several questions. Okay, I try. Yeah, during the audit, we actually look for also reduction of pollutions, and it's just an example. We had a customer that was actually using nitric acid for pH neutralization for convenience purposes, and actually it gave him nitrate issues, and he didn't even realize that. And so yes, replacement to substitute some chemicals is definitely something that can be done at the source. And there was a question about phosphate, but maybe I also mentioned that you can also aim to segregate different effluents, and for instance, segregate the one that has the highest pollution in terms of COD, and put that on an anaerobic treatment, and not the rest, which then makes a very efficient and optimized design. And yes, in terms of phosphate recovery, that has been done in the past in the FDM industry. I can think of a cheese factory in Germany, and there are sites in Belgium, I think, on fries, potato fries. And most of them will treat the phosphate, precipitate the phosphate as struvite, which is very rich in ammonia and phosphorus. And of course, it's ideal to do that on an effluent from a methanization plant. In principle, you could also precipitate with calcium phosphate, but I do not know any site that does it in the FDM industry. Did that answer it?
Okay. Yeah, I guess. I guess. Thank you so much. Feel free to post your question. There is one more regarding the last technology. So this is for NutriPack, William. So the question is, our site has to dose coagulants upstream, the clarifier for settlability. So it doesn't make sense to move the coagulant dosing downstream. So what is the value of the NutriPack in this scenario?
Yeah, this is a good point. There are a few things to consider here. Firstly, there is a compliance issue. So can the phosphorus levels be reduced sufficiently with this method? And then secondly, you need to consider how will the extra coagulant. So I was saying that, yeah, firstly, there's a compliance issue. So can the phosphorus levels be reduced sufficiently with this method? And then secondly, how will the extra coagulant affect the stability of the plant? Adding more chemical sludge to the plant will have an effect on the plant performance. And another point, I think Robert mentioned it briefly, which was that BWT offers an organic coagulant alternative that you may want to consider. It's good for the plant stability, but the real value comes from the sludge disposal costs reduction. At one site in Spain, I know that they reduced the sludge production by about 50% by changing the coagulant. And in that case, then you would need to have ferric chloride dose downstream of the plant for the phosphorus precipitation.
Okay. Okay, thank you, William. So I received also a question regarding the presentation. So yes, we will share the presentation with you. Any more questions? Just, we still have 2 minutes. Okay, no more question. So this is the end of our webinar related to BREF for food, drinks, and meat industries. So we will send you in the coming days a survey to get your feedback regarding this webinar. And for those who are really interested to know more about BREF and to get in touch with our team, so the main contact remains Peter Stokes directly. So I take this opportunity to thank you, everyone, and also take this opportunity to wish you a nice day and for sure a nice year end. Thank you, everyone. Thank you, Peter, William, and Robert. Have a good day.
Thank you very much.
Thank you.
Thanks,
Bye-bye.
Bye-bye. Bye.
Bye-bye.